Equivalent fractions is a very simple concept. It does, however, make all of our operations with fractions very complex. So we'll be spending a lot of time on fractions because of this idea of equivalent fractions. Equivalent's a big word, but it's not anything you need to worry about. It simply means that they are equal. Equivalent means equal fractions. And the thing to remember here is that every fraction has an infinite number of equivalent fractions. That's right. Infinite means there's no end to it. It has an endless number. Every fraction, whether it's 1/4 or 1/2 or 1/3, has an endless number of ways that that fraction could be rewritten as other fractions with other numbers that have the exact same value as the original fraction. So you can see that that would make operations with fractions complex enough, because you're never sure what the real simplest form of the fraction is that you're dealing with. Actually, you are sure about it, but you have to know how to do that. We're going to go back to our apple here that we first divided when we were explaining fractions. We divided it straight down the middle equally into 2 halves. So we have 1/2 of an apple. Okay. Now we're going to divide it again. Now we're going to divide it as if we had divided it perfectly into 4 parts. Now remember, we divided it into 1/2, and we had this part of it, the part that's shaded in. Okay, now we divided it again into quarters, and we have 2 quarters, but isn't that the same 1/2? 2 quarters of the apple is equal to 1/2 of the apple. What if we divide it again? Let's say we divide it again. We take each part and we divide it again perfectly so that they're all equal parts. Now we have 1, 2, 3, 4, 5, 6, 7, 8. Now that half that we started with is now divided into 1, 2, 3, 4 parts. And the total number of parts is 8, right? And we have 4 of them. So 4/8, 1, 2, 3, 4/8, that's also equal to 1/2, isn't it? It's also equal to 2/4. Now if we divide this apple again, the same thing will happen. But we will end up with 8/16 this time. If we divide each of those pieces in half, we'll end up with 16 pieces, and in our half of the apple we'll have 8 of them. If we divide it again, we'll end up with 16/32. If we divide it again, we'll end up with 32/64. Now, we can continue to divide that apple endlessly. Of course, if it's a real apple, eventually it's going to be pulp. But theoretically, and in a lot of applications with math, we're not dealing with apples, so you can divide something into pieces without any end to it. To illustrate that process, we use 3 dots. That means it goes on and on, even to infinity. Infinity means without end. So we've shown a little part of the process, a process that can continue forever. By continuing to divide this fraction in half, you continue to end up with fractions that are all equal. Every one of these fractions is equal to 1/2. Every one of these fractions is equal to 2/4. All of these fractions are equal. It's the same fraction, but we can represent it in an infinite number of ways. That is what makes operations with fractions complex. So we're going to spend more time on them so that you'll learn how to make them simple. There's only one thing that you need to come away really understanding at this point, and that is the way we would transform these fractions without having to take an apple and cut it into pieces. Some of you have noticed that there's a pattern here. Look, this 2 here turns up there. 2 doubled is 4. This 4 turns up there. 4 doubled is 8. This 8 turns up here. 8 doubled is 16. So each of these numbers is doubled. 1 becomes 2, 2 becomes 4, 4 becomes 8, 8 becomes 16, 16 becomes 32. And look down here, each of these numbers become doubled. 2 becomes 4, 4 becomes 8, 8 becomes 16, 16 becomes 32, 32 becomes 64. The fact is, it is if we have multiplied each one of these fractions by the same multiplier. We call that a factor, by the same factor. We multiplied 1 times 2, and that's equal to 2. And we've also multiplied 2 times 2. That's equal to 4. We have doubled it. To double it means we multiply it by 2. Then to get the next fraction, we did the same thing again. 2 times 2 is equal to 4. 4 times 2 is equal to 8. Then to get the next fraction, we did exactly the same thing. 4 times 2 is equal to 8. 8 times 2 is equal to 16. Then to get the next fraction, we did exactly the same thing. 8 times 2 is equal to 16. 16 times 2 is equal to 32. And again, 16 times 2 is equal to 32. 32 times 2 is equal to 64. This is the rule I want you to understand about equivalent fractions. If you want to create an equivalent fraction, or later on, of course, we want to simplify fractions, any time that you multiply both the numerator and the denominator by the same number, by the same factor, the result will be an equivalent fraction. Let's try that rule again. Anytime you multiply both the numerator and the denominator by the same number, by the same factor, you will have an equivalent fraction. Now that also goes for division. Anytime you divide both the numerator and the denominator by the same factor, by the same number, you will end up with an equivalent fraction.